Okay, so let's unpack this. There's so much buzz about electric vehicles these days, all shiny new tech and, well, green promises.
Definitely a lot of hype.
But let's be real, for some pioneering owners, the journey to electrification has been less smooth sailing and maybe more like an unexpected detour.
More like a detour through a minefield of mystery repairs sometimes, based on what we've seen.
Exactly. Mystery repairs and bewildering bills.
Yeah.
So today, we're taking a really candid look at the actual real-world experiences of owning an EV.
From the perplexing problems that pop up.
Right, to the ingenious solutions that are actually already on the horizon. Our mission in this deep dive is basically to cut through all that noise.
Yeah, give you a clear, balanced perspective. We've pulled together a stack of sources here.
We really have everything from, in-depth warranty analyses, technical journals.
To passionate mechanic reports, even lively online discussions from owners themselves.
So you can navigate the whole EV landscape feeling, hopefully truly well-informed. Get ready for a comprehensive and, I think, pretty entertaining exploration.
Let's dive in.
Okay, so let's kick off with some of those, oops, that's expensive moments, the kind that make you question your life choices at 2 a.m.
We've all had those moments. Maybe not EV related, but...
Right. Well, it turns out a significant chunk of consumers are really hesitant about EVs, mostly because of what they imagine might happen if the battery goes kaput.
it's a big unknown for a lot of people.
Totally. And AAA's survey actually showed a whopping 62% of consumers cite high battery repair costs as a key barrier. And honestly, with some of these stories, you can see why.
Some of the early stories were pretty rough, yeah.
Take the Renault Twingo, for instance. We found this just absurd anecdote from EV Clinic. One of these little cars was deemed a massive €20,000 total loss.
20,000 euros for a Twingo?
Yes. Because of some minor damage to the battery housing. The, quote, for a new battery alone, 16,000 now, plus VAT.
Wow. That's more than the car's probably worth.
Right. And here's the kicker. This is where it gets really interesting. The actual repair, after some clever folks really dug into it, cost only about €340.
340 euros?
Yeah.
Compared to 16,000.
Yes. We're talking a coolant deflector, a bit of protective plastic, an aluminum end cap. That's it. It's an astonishing difference, isn't it?
It really is. And that Twingo story, as frustrating as it sounds, it kind of perfectly illustrates a significant challenge from, let's say, the earlier days of EV repair.
Okay.
You had this initial lack of specific diagnostic tools, maybe not enough trained technicians,
Right.
coupled with manufacturers often defaulting to just replacing the whole battery instead of fixing the specific bit. That led to these kinds of wildly inflated estimates.
Oh, okay. So that explains some of it. But it still makes you wonder how many other owners are getting, well, fleeced.
It's a key reason why some of those consumer fears you mentioned, while maybe valid back then, are being actively addressed now.
Good to hear, but the stories keep coming. It's not just the Twingo. We have the Smart 453 EQ. One owner faced a just staggering €12,000 bill.
12,000, what for?
Drivetrain and motor replacement. Apparently, an inverter burned out and the rotor melted. And get this, the car only had 20,000 kilometers on it.
20,000 K, that's barely broken in.
I know. It just shows how quickly a seemingly minor fault can escalate into these astronomical expenses when you're dealing with complex EV components.
Absolutely. Integration is great for efficiency, but can make repairs tricky if not designed well.
And don't even get me started on hybrids. For hybrid owners, it can feel like an, I don't know, apocalyptic reality sometimes.
Hybrids have their own set of battery challenges, for sure.
Batteries are often the most expensive parts, sometimes costing 12,000 to 20,000 colons, and they often need replacing after just 100,000 kilometers.
That's quite a limited lifespan compared to full EVs these days.
Right. If you do the math, that makes your electric driving costs around €17 per 100 kilometers just for the battery part.
Ouch. That eats into the fuel savings pretty quickly.
Totally. And that myth, battery regeneration, EV Clinic flat out says it does not exist. Sorry, folks, no magic fix going to bring a degraded hybrid battery back to life.
Regeneration helps with efficiency while driving, but yeah, it won't reverse chemical degradation in the cells.
So, okay, you somehow navigated the initial sticker shock of a potential repair. But what happens when you turn to your warranty?
The safety net, supposedly.
Supposedly. Well, that can often be its own warranty wonderland. Or maybe, as some owners might call it, the warranty wasteland.
Wasteland, that sounds harsh.
Well, some manufacturers seem to have a real talent for denying claims faster than you can say electric vehicle.
Okay, like who?
Take Stellantis, that's Peugeot, Citroen, Opel, Fiat. EV Clinic has some just egregious examples. They controversially call it warranty abuse or unjustified warranty denials.
Warranty abuse is a really strong term. What kind of examples are we talking
We're
about?
talking warranty denials for absurd reasons,
Hmm.
like missing a scheduled washer fluid refill.
Wait, washer fluid? Seriously?
Yes, or, get this, legally questionable practices like rejecting warranty claims for imported vehicles, even if they were imported within the EU.
That does sound concerning. Intra-EU imports shouldn't typically void a warranty like that.
And it's like they're trying to find any loophole, to make you pay out of pocket.
While those examples are certainly alarming, if accurate, it does speak to the immense frustration some owners have faced. It probably highlights a larger issue of manufacturers defining terms very strictly sometimes.
Maybe, but it feels pretty unfair from the owner's side.
I understand that. But it's also worth remembering, as we'll get into, that the majority of OEM EV warranties are actually quite robust these days. And the industry is pushing for more transparency.
Okay. Then there's the Fiat 500e. This one seems to suffer from what EV Clinic calls programmed obsolescence.
Programmed obsolescence, that's another loaded term. What's the issue there?
We've seen reports of recurring battery failures at really low mileages, like between 5,000 and 50,000 kilometers.
That's incredibly low.
Yeah, right. And the problem, apparently, is deliberately implemented safety features or some kind of software issue that locks and just deactivates perfectly functional batteries.
Locks them out. So the battery might be fine, but the software says no.
Exactly. Forcing owners to fork out $13,000 for a replacement. Thankfully, EV Clinic has figured out a workaround. It involves like 100 work hours and EEPROM modifications.
So reprogramming the car's permanent memory chips, that's complex stuff.
Very. But it bypasses the software problem. Still, you have to ask, who designs a car to potentially fail like that after so few miles? It just adds to the skepticism.
It certainly raises questions about software design and long-term support strategies, especially in those early models.
And let's not forget the Tesla unsupported trap. This sounds scary.
Ah, yes, the unsupported designation.
If a Tesla gets marked unsupported, maybe because someone tampered with it, or it was imported from the US, or had a major accident,
Right, usually after significant events or modifications outside Tesla's control.
it can lead to permanent deactivation of supercharger access, service bans, and your warranty. Poof, gone.
It essentially bricks certain functionalities and official support, yeah. It's Tesla's way of managing liability on cars with potentially compromised systems.
Talk about being left in the lurch. You've got this incredibly expensive brick in your driveway.
It's a serious consequence, definitely something potential buyers of heavily modified or salvaged Teslas need to be aware of.
Okay, so now, if you manage to avoid the warranty pitfalls, you might still face the mechanic's nightmare, which of course quickly becomes the owner's nightmare too.
The repair process itself.
Yeah. According to EV Clinic, European engineers are absolute global leaders in designing, wait for it, utterly stupid, unsustainable, expensive, and complex maintenance systems.
Wow, okay, that's quite a statement. Not holding back there.
Not at all. And they've got stories. Remember that Renault Twingo R240?
The one with the coolant leak?
Yeah. Just to identify that simple leak, technicians had to disassemble everything down to the last bolt. Suspension, drive shafts, the works.
Just to find a leak.
Yes. That's 5 to 10 hours of labor. We're talking about a €1,000 court just for a mechanic to take a look.
€1,000 for diagnosis. What was the cause in the end?
Get this. A manufacturing defect. A factory-drilled hole had pierced the coolant channel.
Oh, come on. A misplaced drill hole caused all that disassembly.
Seriously. It's just mind-boggling how complex they made accessing basic things.
That highlights a huge issue with early EV packaging prioritizing space over serviceability sometimes.
And the diagnostic headaches seem constant. You get these inconsistent, proprietary, or just generic fault codes, like pack imbalance.
Okay, pack imbalance. But does it say where the imbalance is?
Nope. No specific module identification. So instead of knowing exactly which part of the battery is the problem, technicians get this vague error.
Which forces them to do time-consuming manual checks on every module.
Exactly.
Yeah.
Bloating diagnostic time and, guess what? Increasing costs. It's like having a check engine light that just says engine problem, not helpful.
Yeah, lack of granular diagnostic data is a major frustration for repair shops.
And a huge pet peeve for EV Clinic. Pouch cells.
Ah, the pouch versus prismatic versus cylindrical debate.
They state, pretty bluntly, the most problematic battery systems are those with POUCH cells. these flexible foil-like cells.
Less structural protection built in compared to the metal cans of cylindrical or prismatic cells.
Right. Highly prone to swelling, overheating, notoriously difficult, maybe impossible to repair.
Swelling is a common failure mode, yeah.
Yeah.
It can damage surrounding cells too.
They even single out the Nissan Leaf, saying it has one of the worst chemical configurations and calling it shameful to even call this vehicle electric because of these issues.
Wow, that's incredibly harsh language about the Leaf.
It is. But they're talking about unrepairable, swelling, overheating cells. Pretty strong condemnation.
The early Leafs definitely had challenges, especially with battery degradation in hot climates due to their passive thermal management. Pouch cells were part of that equation.
So, okay, after all these potential financial landmines and mechanical hurdles, what about the depreciation drama?
Ah, the resale value question. Always important.
You see a lot of chatter online, like on Reddit, about used EVs being a steal right now.
Yeah?
People bragging about 50% depreciation on, say, Ford Mach-E or VW ID.4 after just a couple of years.
Yeah, there have been some significant price drops in the used market recently. Great if you're buying used.
Great for buyers, sure. But it's a double-edged sword, right?
Mm.
It's also a clear sign of market uncertainty and that nagging fear of the battery pack failing.
True. Uncertainty about battery health and replacement costs definitely impacts used value.
Nobody wants a potential multi-thousand-euro repair bill hanging over their head on a car that's already lost half its value.
That's a valid concern.
This leads to what one Reddit user perfectly called the paperweight fear.
The paperweight fear.
Yeah, the concern that an out-of-warranty battery failure could basically turn your shiny EV into a really expensive paperweight,
Yeah.
especially with new battery tech always emerging.
Making the old tech seem obsolete or harder to fix.
Exactly. It's a gamble many just aren't willing to take. So, I mean, with all these challenges and fears, does the industry have any real answers? Is there like a light at the end of this tunnel of mystery repairs?
Absolutely. Yes, definitely. That paperweight fear and all the hurdles you've just laid out so vividly.
Well, they're real stories.
They are, but they're not going unaddressed. In fact, what's truly fascinating is how rapidly the industry is evolving, directly tackling these very frustrations head on.
Okay, that's good to hear.
While the challenges you highlighted are real, and they certainly shaped early perceptions, they are precisely what's driving this rapid innovation. The future of electric mobility is being built with greater serviceability and sustainability as core goals.
So, how are they doing that? Let's start with warranties. You mentioned those abuse examples.
Right. While those examples are frustrating, let's balance the picture. Most OEM EV warranties are actually quite comprehensive now. They typically cover 8 or even 10 years, and at least 100,000 miles, sometimes more. And critically, they cover significant battery capacity loss, usually if it degrades beyond 25–30%.
So it's not just if the battery completely dies, but if it gets significantly weaker.
Exactly, which addresses a major concern. And you see companies like VinFast offering an impressive unlimited mileage warranty for 10 years. That really sets a high bar for consumer confidence.
Unlimited mileage for 10 years. Wow.
And beyond the manufacturer's coverage, you can get extended warranties for both new and used EVs, picking up where the original one ends. The key, of course, is always.
Let me guess. Check the fine print.
Always check the fine print, especially for specific battery coverage details. But the options are there.
Okay. But are the batteries themselves actually lasting, or are we all going to need that warranty?
That's the other crucial point. The durability is often underestimated. According to Recurrent, the EV battery analytics firm,
Yeah.
they state clearly, EV batteries rarely need to be replaced, and battery costs are getting cheaper.
Cheaper is good.
And even EV Clinic, despite all their horror stories, notes that the battery is often the last concern on the list during the first 10 years of an EV's life.
Huh. So maybe not the ticking time bomb people fear.
Not typically. We've seen data like some Tesla Model S batteries lasting over 598,000 kilometers. That directly counters that paperweight fear.
Nearly 600,000 kilometers. Okay, that's impressive.
And when it comes to cell types, those reliable cylindrical cells and prismatic cells, the ones in robust metal casings, common in many modern EVs, they consistently outperform the problematic pouch cells you rightly called out. The industry is learning and moving away from less robust designs.
Okay, better warranties, longer-lasting batteries. What about actually fixing them when something does go wrong? Avoiding that Twingo nightmare.
Exactly. Beyond the warranty, how do we make these vehicles easier to live with and repair? That brings us to a really crucial area. A strategic industry shift towards designing for serviceability.
Designing for serviceability. So thinking about the mechanic from the start.
Precisely. It's a pivot from focusing only on performance or range metrics to also prioritizing how easily an EV can be maintained and repaired in the real world.
Makes sense. How does that look in practice?
Modular battery architectures are leading this revolution. This directly addresses those mechanics nightmares you described.
Like needing to take everything down to the last bolt.
Exactly. Remember that Twingo? Modular systems, as highlighted in sources like the World Journal of Advanced Research and Reviews, improve diagnostic accessibility. They can slash disassembly times by up to 60%.
60%? How?
Because technicians can often isolate a fault to a single module, maybe swap just that module out, without ripping apart the entire battery pack.
Ah, like Lego bricks instead of one solid block.
Kind of, yeah. It creates a much more streamlined service pathway. Saves time, saves money, potentially lowering service costs by up to 40%, and it significantly improves safety for technicians, reducing hazard exposure.
Okay, that sounds like a massive improvement. Are car makers actually doing this?
Oh yes, leading OEMs are actively embracing modularity. GM's Ultium platform, for instance, it features module-level voltage and thermal reporting.
So the car tells you exactly which module has the problem.
Yes. And it has rapid disconnection connectors for quick, safe servicing. Rivian uses a stackable modular configuration with accessible panels and external diagnostic ports. Even Ford has adopted modular designs across its platforms.
What about Tesla? They're often seen as leaders.
Tesla's approach has been a bit different. Their highly integrated structural battery design is incredibly efficient for manufacturing and performance, but it historically presented challenges for serviceability, with limited third-party diagnostics.
So harder for independent shops to work on.
Traditionally, yes, though even they are evolving, but the broader industry shift towards modularity for serviceability is very clear.
All right, modular is good. What else is helping fix those diagnostic headaches, the vague error codes?
Great question. To enhance the whole repair ecosystem, we're seeing exciting developments in diagnostic capabilities too. Future repairs will be powered by smart tech that makes those vague pack and balance errors a thing of the past.
How smart are we talking?
We're talking about predictive diagnostics embedded right at the modular battery management system, BMS level. The battery itself can often tell you exactly what's wrong, where, and maybe even before it becomes a major issue.
Okay, predictive diagnostics. I like the sound of that.
We're also seeing innovations like electrically smart fasteners. Imagine a bolt that electronically reports its installation status.
A bolt tells you if it's tight enough.
Exactly. It tells a technician if it hasn't been torqued correctly, potentially preventing future leaks or structural issues before they even start. And manufacturers are using CAD and digital twins more to simulate serviceability during the design phase.
Catching problems on the computer before building the car. Smart.
And a really vital push is underway for standardization. This is a potential game changer for independent garages.
Standardization. How so?
Things like open source service communication protocols, harmonized error codes across brands, standardized diagnostic interfaces like UDS and OBD2 compatibility.
The same kind of plug-in diagnostics regular cars use.
Essentially, yes. Making it easier for independent garages to plug in, understand what's happening, and perform repairs, just like they do with traditional gasoline vehicles. This interoperability is crucial to empower a wider network of mechanics and reduce that reliance on proprietary ODM systems you mentioned.
That could really open things up and maybe lower costs.
Absolutely. And don't overlook the power of remote capabilities. Cloud-connected BMS modules are increasingly used for remote access.
Like the manufacturer diagnosing my car from afar.
Yes, and performing over-the-air OTA updates for software fixes, remote diagnostics. This improves uptime, especially for commercial fleets, and allows centralized monitoring of battery pack health, helping catch issues proactively.
Okay, so lots of tech solutions coming online. How does this all add up economically and, for the planet?
Yeah, great question. If we connect this to the bigger picture, all these advancements have a significant economic and environmental upside.
So countering those initial cost fears.
Exactly. While initial purchase costs can be higher, in the long run, the total cost of ownership, the TCO, often favors EVs. Even EV Clinic, with all its cautionary tales, notes that EVs can be cheaper to maintain over 200,000 kilometers than traditional cars.
Cheaper even with potential faults.
Yes, especially when you factor in the massive savings on fuel and routine maintenance. Remember the AAA survey? Lower fuel cost and lowest maintenance costs were primary reasons people were interested in EVs.
Right, no oil changes, spark plugs.
None of that. And this modular design philosophy, it ties directly into circular economy goals.
Circular economy. How?
It makes module-level testing much easier. So when an EV battery pack retires from a car, healthy modules can be easily identified and repurposed for second-life applications, like stationary energy storage.
Giving old batteries a new job instead of just recycling them.
Precisely. And when modules do reach the very end of their life, efficient material recovery for recycling is much simpler with modular designs. This reduces the environmental impact and lowers the carbon footprint of making new batteries.
Better for the wallet, better for the planet. Potentially.
That's the goal. Plus, let's not forget financial incentives. Government subsidies and tax credits, like that $4,000 used EV credit in some places, are designed to help offset those initial costs and make the switch more accessible.
Wow, okay. What a journey we've taken here. From those initial tales of woe about repair bills that could buy a small island,
Maybe a very small one.
to the promise of these smart modular batteries that practically diagnose themselves. It's clear the world of EV ownership has been a wild ride. Definitely some growing pains.
Indeed. And what's truly compelling here is that while the challenges you so vividly highlighted are absolutely real,
They needed highlighting.
they did, but they are driving rapid innovation. The industry isn't ignoring these issues. It's actively moving towards those modular designs, standardized diagnostics, better support systems. The future of electric mobility is being built with greater serviceability and sustainability as core principles, making the EV experience increasingly reliable and hopefully more user-friendly.
That's the hope.
And hey, if you've enjoyed this deep dive today, if you found these insights valuable in understanding this, evolving world of EVs, please consider giving us a like and subscribing to the channel.
Yeah, do that.
Your support really helps us continue exploring these fascinating topics, keeping you ahead of the curve.
So wrapping up, what does this all mean for you listening right now? Are these current adventures we talk about just temporary roadblocks on the superhighway to sustainability? Or are they maybe fundamental design flaws we need to demand more from manufacturers on? What stands out to you as the biggest takeaway from today's deep dive?